Guys, so now we will move on to our third lecture. So last time ang diniscuss natin ay all about matrix multiplication. So tapos na tayo sa addition, subtraction, multiplication by a constant, and then matrix multiplication. So ngayon i-discuss natin yung iba't ibang properties that may arise when performing these operations, and then we will discuss different types of matrices, and then partitioned matrices. Okay, so will be our third and last lecture for the prelim. Okay. So first we have theorem 1.1. So we will have properties of matrix addition. So suppose that A, B, and C are M by N matrices. Then we have that the addition of matrices to be commutative. That is, A plus B is equal to B plus A. Okay, and then next one is uh, uh, familiar naman to, no? I think this is the associative property. Okay, so property rin to governing real numbers, pero this time we apply it to matrices. Okay, and then the next one is the existence of an additive identity. That is, meron tayong pwedeng i-add sa isang matrix such that ang resulting pa rin ay yung original na matrix, and then we call this the zero matrix. So basically ito lang yung uh, matrix na ang lahat ng entry niya ay 0. Okay, so kung sa C diniscuss natin yung additive identity, dito naman ay yung tinatawag natin na additive inverse. Okay, so suppose we have a matrix A, meron daw mag-exist na matrix D such that pag inad mo si D kay A ay mag-i-equal siya sa 0 matrix. Okay, and then I think obvious naman na ang tinutukoy natin na D ay si negative A, or yung negative 1 multiplied to the matrix A, and we have the following. So A plus negative A to be equal to 0. Okay? And then we can write it down as negative A or negative 1 times A. Okay, so example 1 here. So we have a matrix for negative 1, 2, and 3. Here we have the 2 by 2 0 matrix, and then if we add that to this 2 by 2 matrix, we will still get the original matrix. Okay, so yun yung and then we have here that an example lang naman, here is the 2 by 3 0 matrix. Okay, understood naman na usually pag 2 by 2 to tapos in-indicate dito 0 lang, it usually means the 2 by 2 0 matrix, kasi hindi naman natin pwedeng i-add yung 0 matrix kung iba yung size niya dun sa pag-aadan natin. Hindi mag-exist yung sum. So kailangan ka-size niya pa rin yung pag-aadan niya. Okay, and then example 2, we have here A and then negative A. So ito yung additive inverse natin. So pag in-add natin siya kay A, ang makukuha natin ay yung 2 by 3 na 0 matrix. So ito yung makukuha natin na sagot. Okay, kasi nga additive inverse siya. Okay, let's move on to properties governing matrix multiplication. So if A, B, and C are matrices of the appropriate sizes, pag sinabi natin appropriate sizes, di ba, pag dalawang matrix pinag-multiply natin, kailangan yung column ng unang matrix ay equal sa row nung second matrix. Okay, so so we have here A times BC is just equal to A times B times C. Okay, so nagigets. So pag sinabi nating appropriate yung BC nag-exist, so dapat yung column ni B at saka yung row ni C ay equal. Okay, and then dito rin naman sa case na to, yung column ni A at saka yung row ni B ay equal. Okay, And then next we have, so again, if A, B, and C are matrices appropriate sizes, we have here parang yung distributive property of multiplication over addition. Parang ganun siya, no? Sa real numbers yon. Pero as we can see, applicable din pala siya sa matrices. That is, if we have A plus B times C, this is just equal to AC plus BC. Okay. And then we have here the third property. So again, if A, B, and C are matrices of appropriate sizes, then ito naman ay distribution property of addition over multiplication. Okay, so C times A plus B is just equal to CA plus CB. Okay. Okay, so we have here three matrices A, B, and C. And then we wish to perform the following operation. So consider this one. So we have gusto nating ipakita na A times BC is just equal to AB times C. Okay, so bago yan, syempre ang parang sa normal na math, ang una natin pinagmumultiply ay yung nasa loob ng parenthesis, ano. So pwede pa nating ipag-multiply si B at saka si C. Yes, kasi si B ay ilan? 4 columns. Okay, and then si C ay 4 rows. So, kung babalikan nyo yung previous module, mag-e-exist yung product nila. So, dito hindi na kinumpute, no? Kayo nang bahalang mag-compute. Pag pinag-multiply nyo si BC, ito yung makukuha nyong BC. Okay, and then multiplying it by the matrix A, we will get the following. Okay? And then, kung ginawa nyo naman yung opposite ay yung isang identity, so A times B muna, pwede bang ipag-multiply si A at saka si B? Yes, kasi si A ay isang, 2 by 3 matrix, and ito ay 3 by 4. So, pag pinag-multiply natin si AB, magkakaroon tayo ng 2 by 4 matrix. So, ito yung AB natin, and then ito si C. Okay, so I'll leave the multiplication to you guys. So, pag-multiply nyo lang si A tapos si B. And then, we get the same value as the first one. So, yeah, true. Medyo true yung associativity ng multiplication. Okay? Okay, so here is just another example of the properties na na-discuss natin. So, here we have A, B, and C. So, A plus B times C is just equal to AC plus BC. So, pareho lang yung nakuha natin na value. Pwede nyo namang i-verify ito. Okay? So, again, kung may gusto kong ipa-verify sa inyo, kailangan nyo lang computein yung isa and then computein nyo rin yung pangalawa and then ipakita nyo na equal siya. No need nang i-prove sa general case kasi hindi naman tayo BS Math students. No? More on, mas concerned tayo sa application nung properties natin. Okay, and then we have here the properties of a scalar multiplication. Again, pag sinabi natin scalar, ito yung constants, ano. Okay, so the first property is just R times SA is just equal to RSA. Okay, and then ito yung dinistribute natin yung matrix natin sa sum ng dalawang scalar. And then dinistribute natin yung scalar natin sa sum ng dalawang matrix. And then, we have here A times scalar multiplication. So, parang nilabas lang natin si R and then we get R times AB. So, basically, ang pinapagana pa rin natin dito ay associativity. Okay? So, again, more examples. So, hindi ko na to isa-isahin, no? Kasi ginagamit lang naman niya yung property. So, medyo basic lang naman. Okay? So here we have matrix A and matrix B. So 2 times 3A is just equal to 6A. So pag kinumpit nyo si 6 times A, pareho lang siya sa 2 times 3A. And similarly, we have A times 2B is just equal to 2 times AB. So nilabas lang natin yung scalar dun sa matrix product. Okay? Parang inilabas natin siya. Okay. Okay, so here we have an application of scalar multiplication. Pwede daw siyang baguhin para pwede daw siyang gamitin para baguhin yung size ng entries ng isang matrix. For example, we multiply the matrix A by K equal to 1/7. Madi-divide lahat yung number entries natin. So, magkakaroon tayo ng 3/7 and then 1, 2/7 and then 1/7. Therefore, the largest value of A will now be equal to 1. Okay? And then, furthermore, kunwari daw si A natin ay nagre-represent ng volume ng products in gallons. Okay? Okay, so if we let K be equal to 4, so kung multiply natin si A ng 4, okay, this matrix will give us the volume in quarts. So, another application lang naman to. Okay, so how about the transpose? Okay, we have here four properties. So, the first part is the transpose of the transpose is just equal to the original matrix. Okay, the second one here is that transpose can be distributed over addition. Okay, so A plus B transpose is just equal to A transpose plus B transpose. And then the third part is that uh, here, pwede natin i-distribute si transpose over the product of two matrices. That is, AB transpose is just equal to B transpose, A transpose. So, merong catch na baliktad. So, nagkaroon tayo ng B transpose times A transpose instead of A transpose times B transpose. Okay? Yeah. And then the next one is, we have here R, scalar multiplication transpose. So, magkakaroon tayo ng R times A transpose. Okay. Sir, bakit nanging ganyan? Isipin nyo na lang kasi na yung isang scalar ay isang 1 by 1 na matrix. So, pag transpose mo yung isang 1 by 1 na matrix, ang makukuha mo pa rin naman ay yung 1 by 1 na matrix na yun. Okay, kasi wala ka naman pagpapalitin na row at saka column. Iisa lang siya. Okay, so now let's proceed to another example. So suppose we have here A and B, and getting their transpose, we get the following. So nag-swap lang tayo ng columns and then rows. Now we want to verify a property. So computing for A plus B, we get this one, and then transposing it, we get this matrix. Okay, now computing for A transpose plus B transpose, we can see that we get the same value as this one. So this one are equal, okay, pero note that this is not a way of proving. Hindi proving yung ginagawa natin. We're just verifying the results. Okay? Okay, and then another example, we have A and B, and then computing for A, B, and then getting the transpose, we get this one. Okay, so 12, 7, 5, negative 3. And then, if we get A transpose and B transpose, tapos ito yung pinag-multiply natin, B transpose times A transpose, which is just equal to this one. So, ito at saka ito ay pareho lang. Thus, again, verifying the previously stated property. Okay, and then, ganun din dito. If suppose we have A and B, okay, to be the following matrices, okay? So, since ito yung property na pwedeng mag-zero yung product ng dalawang matrix maski hindi zero yung matrices natin. Okay? Okay, so punta tayo sa properties natin sa real number. So, tandaan nyo na, di ba pag meron tayong AB equal kay AC, and A is not equal to 0, pwede natin i-cancel si A. And we are left with B equal to C. Okay, pagdating sa matrices, hindi ganito yung case natin. So, kung titingnan natin to, we try natin computein si AB, tapos si AC. Okay, so AB is just equal to AC. So, pareho silang equal sa 8, 5, 16, 10. Pero, maski equal yung product ni AB at saka product ni AC, okay, B is not equal to C. So, yung cancellation ay hindi nag-work pagdating sa matrix multiplication. Okay, so now we proceed to the next module wherein we discuss different types of matrices. So, ito yung mga special na matrix. So, mga matrix na mayroong pangalan. Okay, and then later on, we will discuss an application of matrices or parang extension ba siya, which is the partition matrices. Okay, so the first type of matrix we will discuss is the diagonal matrix. Okay, so from its description, siya yung matrix na ang may entry lang tayo ay yung main diagonal. Okay? So, note that kailangan square yung matrix natin para magkaroon tayo ng diagonal matrix. So, equal yung row at saka equal yung column. So, yeah. So, an n by n matrix A equal to Aij is a diagonal matrix if Aij is equal to 0 whenever I is not equal to J. Okay? So, meaning, yung mga, when I is equal to J, yun lang yung may entries natin. Okay? And then, kung yung entries ng diagonal matrix natin ay equal, so, kumbaga parehong 2, 2, 2, 2, ang tawag natin dun ay scalar matrix. Okay? Yeah, and then we have here the following definition for the identity matrix. Pag sinabi naman natin identity matrix, okay, ayun naman yung lahat ng entry niya ay, lahat ng entry sa diagonal natin ay 1. Okay, for example, here we have the 1, 0, 0, 1. Okay, tinatawag siya na identity matrix kasi pag minultiply mo siya sa any 2 by 2 matrix, ang makukuha mo pa rin ay yung 2 by 2 matrix natin na to. Okay? You can try. And then, meron tayo nung 3 by 3 identity matrix. So, yan naman siya. Okay? Basically, yung diagonal niya ay equal lang kay or yung entries ng diagonal natin ay 1. Again, maski anong i-multiply mo ditong 3 by 3 matrix, ang makukuha mo pa rin ay yung original na 3 by 3 matrix. Okay? Okay. Okay, so let's proceed to example. So we have here three matrices, A, B, and C. So si A dito ay example siya ng scalar. Ng isang diagonal matrix. General na diagonal matrix lang. Si B ay scalar matrix kasi equal yung nasa diagonal niya or pare-parehong 2. And then si I3 dito ay yung 3 by 3 identity matrix natin. Okay? So usually dinedenote natin yung identity matrix by the letter I and then may subscription na number. Yung number na yun ay yung size nung matrix natin. So here we have I3 to be the 3 by 3 identity matrix. Okay, so we have here a property regarding the identity matrix. Okay. So, mali dapat equal to. So, A times the identity matrix is just equal to A. And similarly, kung i-multiply natin siya dun sa left side naman, equal lang siya kay same pa rin na matrix. Okay, so sir, pwede mo naman palang pagpalitin yung multiplication. Note that from our previous discussion, nagwo-work lang to sa identity matrix. Hindi na siya magwo-work or hindi siya necessarily magwo-work for any other matrix. Okay, this property only holds true always for the identity matrix or yung kung isang product natin ay or yung kung isang multiplicand natin ay yung identity matrix. Okay? Furthermore, if A is an identity matrix, then we can write A as R times I7. So, yung diniscuss ko kanina, pwede nga tama naman, pwede natin isolve. For example, we have here ito ay 2 by 2 na scalar matrix, So, yung entry lang natin ay diagonal. This is just equal to 2 times 1, 0, 0, or 1, 0. Okay? And this is just equal to 2 times I2 or 2 times the 2 by 2 identity matrix. Okay, so next we have here two types of matrices. So we have the upper triangular for which A sub ij is equal to 0 whenever I is greater than J. Okay, and then it is called the lower triangular if aij is equal to 0 whenever I is less than j. Okay, so mas madaling makita to by example. So here we have A to be an upper triangular. So obvious naman kung bakit siya upper triangular. Kasi ito lang yung meron tayong entries, and then yung sa baba 0 na lang siya. And then si B ay example ng lower triangular matrix kasi nga yung lower part lang niya yung merong entries, and then 0, 0 na yung nasa taas. Okay? And then we have here another type of matrix which is asymmetric matrix. Okay? So asymmetric matrix is a matrix that is equal to its transpose. Okay? And then here we have another type which is the skew symmetric matrix. We have this if its transpose is equal to negative of A. Okay, ito yung skew symmetric. Okay, so here we have examples 3 and example 4. So example 3 here is asymmetric matrix. So pag kinuha mo yung transpose nitong matrix na to, ang makukuha mo lang rin ay yung original na A. Okay, and then again si B, pag kinuha mo, ano nga yung property ng skew symmetric, pag kinuha mo yung transpose niya, equal lang siya kay negative B. Okay, so this one is an example of the skew symmetric matrix. Okay, so now we proceed to the partitioned matrices. Pero bago tayo mag-proceed, mag-discuss sa partition matrices, i-define muna natin kung ano sub-matrix. So, suppose that we have an m by n matrix and then meron tayong kinancel na columns or may kinancel tayo na row. Pag sinabi natin kinancel, inalis natin, okay? Mag-o-obtain tayo ng isang sub-matrix ni A. Okay, so here an example is we have A. Okay, if we cross out the second row, so i-cross out na natin si second row, hindi natin siya isasama, and then alisin daw natin si third column, and then kunin natin yung entries which is 1, 2, 4, and then 3, 0, negative 3. Okay, ito ay isang sub-matrix. Sub-matrix siya ni A. Okay? Pwede rin namang alisin mo to tapos ito, or pwedeng isa lang yung alisin mo, pwedeng ito lang yung alisin mo, ganyan, submatrix pa rin siya, no? Okay? Pero wag mo i-cross out lahat. Pag inalis mo lahat, edi wala ka ng matrix. Okay? Okay, so now let's discuss partitioned matrices. So, pag sinabi nating partition, di ba ang ginagawa natin, hinahati natin siya into parts. Basically by adding lines, okay? Either vertical or horizontal lines. Okay, so makita natin to dito. Okay, so suppose we have a matrix A. So ito ay ilan? 4 by 5 na matrix. And then pwede natin siyang i-partition into this way. So nagkaroon tayo ng yung tinatawag natin na sub matrices. Okay, so we have here, so ito yung tatawagin natin na A11. Ito yung submatrix na A11. Ito si submatrix na A12, submatrix A22, at saka si submatrix A21. Okay, and then meron ding ibang way kung paano hatiin to. Okay, so pwede natin siyang hatiin dito. Okay, and then we are left with 6 naman. 6 submatrices. Okay, so tatawagin natin siyang A11 hat, A21 hat, A12 hat, A22 hat, A13 hat, at saka A23 hat. Sir, bakit natin nilagyan ng hat? Kasi ano lang naman yan, for notation purposes lang. Kasi meron na tayong A11 dito. So pag inequate natin siya ng A11 ulit dito, magkakagulo tayo. So nilagyan lang siya ng hat for annotation purposes. Okay? Okay, so let's proceed to another example. So yung augmented matrix natin ay isang example ng partition matrix. So pinartition natin siya in a way na nakahiwalay yung B natin. Okay, so kung natatandaan nyo. And then yung A, recall that yung A natin dito ay yung ating coefficient matrix. Okay, so dito sa paragraph na to is meron tayong kung si A at saka si B ay pareho ng pagkaka-partition and then pareho sila ng size, pag inad natin si A at saka si B, pwedeng equal lang siya sa, pwede natin makuha si A plus B by adding the sub matrices. So, for example, i-add natin si A plus B ay na partition as a 2 by 2. So, meron tayong A11, A12, A21, A22, B11, B12, at saka B22. So, since pareho sila ng pagkakapartition, pwede mo lang i-add si A11 kay B11. Pwede mo ring i-add and then para mag-proceed, i-add mo si B12 kay A12. Ganun lang naman siya. Okay, so another one is the uh, pa- uh, application ni partition pagdating sa multiplication ng matrices. So, ang gagamitin natin dito ay si A. So, yeah, so we have here A is 4 by 5 and B here is 5 by 4. So, pwede natin siyang ipag-multiply. Okay, so if A is partitioned in this way, so we have this one. Ganito yung pagkaka-partition. Pwede daw natin siyang i-multiply kay B. Okay? Pwede ba? Entry per entry. Ito ay 2 by 2. So, itong entry na to ay 2 by 2. So, possible. 2 by 2 rin to. So, yung entry na to ay 2 by 2. So, yeah, I think it's possible. And then, we have here A. So, itong B31 natin ay isang 2, 1 by 2. And then, kung i-multiply natin siya kay A13, meron tayong 2 by 1. So, yes, possible yung multiplication. Okay? So, pwede nyo i-verify to that A times B is just equal to the following. Okay, pwede pala tayong, para hindi na natin, kasi sobrang laki, diba? Imagine mo kung i-multiply mo itong 4 by 5 sa 5 by 4. So, sobrang laki ng computation. So, instead of dealing with the entirety of those two matrices, pwedeng mag-perform na lang kayo ng small multiplications in the form of partitioned matrices. Okay? Okay, so we have here another example. So, example 8. So, here we have A to be equal to a 4 by 4 matrix. Okay, partitioned into 4 2 by 2 matrices. And then B is a 6 no, it's a 4 by 6 matrix. So, pwede ba natin sila ipag-multiply? Yes, kasi yung columns ni A, yung bilang ng columns ni A ay equal sa rows ni B. So, again, matrix multiplication is possible. Okay, so pag pinag-multiply natin sila, and then na-partition natin siya in this way, okay, pwede natin, mas madali pa lang i-compute yung matrix product nila. So, ganoon lang rin, no? So ito ay, pwede ba natin siya lang ipag-multiply? Kasi, kung natatandaan nyo dun sa matrix multiplication, okay, so parang yung pag-multiply lang sa matrix multiplication, ito, i-multiply natin dito. Okay, so ganun lang rin. We'll proceed as usual. Okay, so doing this, we get the following. A times B is just equal to the following matrices. Okay, where C11 is equal to A11, B11 plus A12, B21. Okay, so kayo na lang mag-verify niyan. Ang sinasabi lang naman dito, pwede natin gamitin yung partition matrices to compute the product of very large matrices. Okay. Okay. So, meron daw tayong tawag dito. So, ang tawag natin dito ay block multiplication. Okay. So, block multiplication. So, kung meron kayong calculator, pwede nyo munang step by step, like ang gagamitin nyo ay block multiplication. Pwede nyo munang unahin yung unang block and then isave nyo siya into memory, and then saka nyo na lang pagsama-samahin yung data. Yes, meron mga calculator na capable ng pagko-compute ng multiplication ng very large matrices. Okay, so here we have an example again. So we have B, C, and D. Okay, then BD. Okay, so parang pinagsama natin yung B at saka sa D, we get the following partitioned matrix. And DC is equal to the following. Okay? So, parang example lang naman to on how we can use partition matrices. Okay? Okay. Yeah. And then, pwede tayo mag-perform ng operations sa partitioned matrices given that appropriate naman yung size natin. Okay, so parang ito, hindi naman siya necessarily operations, parang pinagsama-sama lang natin siya. Okay, so dito finorm natin si partition matrix na BD. So ito si B, ito si D, and then ito si D, ito si C. Meron tayong partition dyan, and then pwede rin yung mas complex na DC, CT. Okay, so here we have more complex partitions. Okay, so now, discuss na natin yung ibang applications ng partition matrices. Suppose that yung isang company ay nire-record niya yung sales niya over 12 months in a year. So, i-store niya yun sa isang 1 by 12 na matrix. And then, kung gagawa siya ng collection ng data, so, ipag-join niya lang yung mga, so, meron tayong matrix, meron tayong partitioned matrix na ang laman ay yung sales per year, per month. Okay, so magiging mas maayos and then mas organized yung data natin. Okay, and then another application is yung na-discuss na natin to. So, yung pagsulat ng isang linear system as an augmented matrix or as a partition matrix. Later on, makikita nyo na writing a linear system and solving it in the augmented form is easier than doing algebraic manipulations. Okay? Okay. Now we will discuss another type of matrices, another type of matrix which is the non-singular matrix. Okay? Okay, so kanina diniscuss natin yung additive inverse and then yung additive identity. So this time we will discuss the multiplicative inverse. Okay, pag sinabi natin multiplicative inverse, pag minultiply mo siya dun sa function dun sa matrix natin, ang makukuha natin ay yung identity matrix. Okay, so let's proceed to the definition. So suppose we have a square matrix A. Okay, non-singular siya or invertible if there exists an n by n matrix B such that AB is equal to BA is equal to IN. Okay, ano to na hindi siya plus, this one is equal. Sorry, may mistake. Pakibago na lang rin sa module nyo. So, yan yung definition ng identity. AB is equal to BA is equal to IN. Okay? So, yung B, ang tawag natin dito ay yung inverse ni A. Okay? So, pag walang nag-i-exist na inverse ni A, ang tawag natin sa kanya ay singular or non-invertible. Okay? Madali lang naman tandaan, no? Pag singular or single ka, malamang wala kang partner. So, wala kang inverse. Yeah. Okay, so suppose we have here A and B. So, since A times B is equal to BA, okay, so pwede nyo i-verify na lang to. Ipag-multiply nyo si A taka si B, tapos si BA, ang makukuha nyo ay ito, 1, 0, 0, 1. Okay. So, since nag-exist si B, we can say that B is an inverse of A. Therefore, A is non-singular. And similarly, B is non-singular. Kasi ang inverse din ni B malamang ay si A. Okay? The inverse of a matrix, so we have here theorem 1.5, the inverse of a matrix if it exists is unique. Okay? So, isa lang yung inverse ng ating matrix. Okay? So, kung meron tayong matrix and nag-exist yung inverse niya, yung inverse na yun ay nag-iisa lang niya. Wala ka ng ibang mahanap na matrix. Okay, so sir, paano po ba natin hahanapin si A at saka si paano natin mahanap yung inverse? Okay? So suppose we have here a matrix A equal to 1, 2, 3, 4. Okay? So ilelet muna natin si A inverse to be the matrix A, B, C, D. Okay? So sabi natin para maging inverse siya, pag minultiply natin yung A inverse, okay, ang makukuha natin ay yung identity matrix. Okay? Now, i-perform nyo lang yung regular na matrix multiplication dito. Okay? And then, magkakaroon kayo nito. Okay? Note that two matrices are equal if their entries are equal. Okay? Kung naaalala nyo. So, dapat ito equal dito, ito equal dito, ito, so on and so forth. So, we arrive with a system of 4 equation. So, kailangan nyo siyang isolve. Okay? Kailangan nyo isolve tong apat na to. And then, kung ano yung solve nyo na value ni A, B, and C, saka ni D, ipasok nyo lang siya dito. Yun na yung inverse nyo. Okay, so in this case, solving for A, B, and C, we get A equal to -2, B equal to 1, C equal to 3 halves, and then D is equal to -1 half. Pwede natin siyang verify or baliktarin natin siya. Okay, baliktarin natin siya. Gawin naman natin A inverse times A. Again, equal pa rin siya sa 2 by 2 identity matrix natin. Therefore, since nakahanap tayo ng inverse ni A, non-singular siya. Okay, another example. So, ganun pa rin, no? So, let A, and then si A inverse, isulat muna natin siya as A, B, C, D. Ipag-multiply, and then equate kay identity matrix. Now, we solve this matrices. Okay? So, na-discuss naman na natin sa first module natin kung kailan hindi nag-exist yung solution ng isang module. So, from here, so, isosolve nyo. So, since wala daw siyang solution, itong system of 4 linear equations na to, we can conclude that wala siyang inverse. Okay, therefore A is singular. Okay, so we have theorem 1.6. If A and B are both non-singular, so meaning pareho sila may inverse, then AB is also non-singular. So meron ka rin mahahanap na inverse ni AB. Okay, and then yung inverse daw ni AB ay equal lang kay B inverse saka kay times A inverse. Okay? So, we have here a corollary. Parang pag sinabi natin corollary, extension ng theorem. Ano? Okay, yun yung meaning ni corollary. Okay, so suppose that we have R na A matrices, non-singular, lahat sila may inverse. Okay? Then yung product nila, okay, ay meron ding inverse. At saka yung inverse niya ay equal dito. Okay, so parang application lang ng theorem 1.6. Okay? Furthermore, if A has an inverse or A is non-singular, then yung A inverse mo rin ay meron din siyang inverse. And the inverse of the inverse is just equal to A. Okay? Suppose now, application naman ni transpose at saka ni inverse. So, suppose that A is non-singular, then its transpose is also non-singular. Furthermore, we have A inverse transpose is just equal to A transpose inverse. Okay? Okay, so trying out the previously discussed theorem. So, suppose we have 1, 2, 3, 4. Finding its inverse, we get this one. So, pag kinuha mo yung transpose ng inverse, we will get the following value. And this is just equal to the inverse of the transpose. So, yes, A inverse transpose is equal to A transpose inverse. Okay? Okay. Okay, so punta na tayo dun sa application ng matrices sa linear. So, paano ba natin gagamitin yung inverse sa pagsosolve ng linear system? So, suppose that we have an n by n matrix. So, tatawagin natin siyang A. Then, yung linear system natin, AX equal to B, ay system ng n equations na merong n variables or n unknowns. Okay? So, if A is non-singular or merong inverse si A, okay, pwede nating i-multiply si AX equal to B ng A inverse para makuha to. Okay, so minultiply natin siya ng A inverse sa left side. Okay, since matrix multiplication is associative, pwede nating pagsamahin siya dito. Okay, and A inverse times A is just equal to the identity matrix. And anything multiplied to the matrix identity matrix will be the matrix itself. Therefore, we can compute the values for A for X. Okay, note that X here, kung natatandaan nyo siya, hindi lang siya X, no? Ano siya, matrix din siya ng mga iba't mga variables. Okay? So, pwede lang pala natin makuha yung value ni X by finding A inverse and then i-multiply natin siya kay B. Okay? Okay, so since x equal to A inverse of B is a solution and alam natin na si A ay non-singular, yung inverse natin ay unique. Therefore, itong solution na makuha natin using this process is also unique or wala na tayong ibang makukuha solution. We state this as the following, sabihin na lang natin na theorem din. So, if A is an n by n matrix, then the linear system has a unique solution, x equal to A inverse B. Okay, moreover, if B is equal to 0, then the unique solution to the homogeneous system is AX equal to 0. AX equal to 0 is equal to X equal to 0. Okay? Basically, nagpa-follow lang to sa property ng inverse na unique siya. So, since unique yung A inverse, okay, A inverse plus B, which is the solution, will also be unique. Okay? Okay, so suppose na kung meron naman daw tayong isang linear system na nagbabago-bago si B, okay, pwede lang nating, yung si A inverse, minsan lang natin kukomputin and then i-multiply lang natin siya kay B, depende kung ano yung value ni B. Kaya minsan lang natin kukomputin si A inverse and then para mahanap yung solution ng linear system, i-multiply lang natin siya kay B. Okay, so we have here an example. Suppose that A is the following matrix and B is equal to 8, 6, B. Okay, then the solution to the linear system AX equal to B is the following matrix. Okay, so we have here, pinag-multiply lang natin siya. So, ang solution natin ay negative 10, 9. So, kung meron tayong matrix na A equal to, so hanapin natin si x1 at saka si x2, equal lang siya kay negative 10, 9. Okay, so si x1 natin ay 10, si x2 natin ay 9. Okay, it's that simple. And then sabi natin, since na-compute na natin si A inverse, mahanap na natin, and then kung ibahin natin si B, ang gagawin lang natin ay i-multiply natin si B kay A inverse. So, in this case, kung inibin natin si value ni B, x equal to x1, x2 is equal to 0. 5. Sir, paano natin nasabi na dalawa lang? Kasi nga 2 by 2 lang naman yung matrix natin. Note that ito ay two equations in two unknowns. Okay, so that is one example of an application. Okay, so that is it for our third lecture. So next week we will be having our prelim examination. Okay, I'll send over the modules after 1 hour. Okay, so thank you for listening.